Good morning, guys. Happy Thursday. Well, it is Thursday for me. I don't know what day it is for you guys, but I'm hoping you guys are having a great morning so far or afternoon. So today what we're going to be doing is quickly going over what we did yesterday or the previous day on lesson 11.2. So just a little recap. We reviewed how to find the area of a sector, and then we were talking about the sector itself using the Math is Fun website. So remember that to find the area of a sector, we are using the central angle. We're going to be using this one. So we're using the central angle, multiplying that by the area of a circle, which is pi r squared, and then dividing that by 360, and that would give us the area of a sector. And then we went and we finished these examples. Now last time I also ended the class with an exit ticket, and so this was the question that I gave you guys. It was a blank of a circle is the region bounded by two radii of the circle and their intercepted arc. Well, if you had time to think about it, and hopefully you were able to solve this, it's a sector of a circle is the region bounded by two radii of the circle and their intercepted arc. Okay, so that was just a little quick review for that before we actually move on to 11.3. Today our goal is to find areas of rhombuses and kites, as well as to find the angle measures in regular polygons and to find the areas of regular polygons. So that is our goal. So the very first thing that we're going to start off, this is actually Cornell Notes style. Again, something that we've been doing pretty often in class. So on this side, I have the area of a rhombus or kite is d1 times d2 over 2. So I'm going to go ahead and explain first the pictures and then what the d's mean. So in this picture, we have a rhombus, and we have a rhombus has congruent sides. Now here I have this labeled, so from here to here is a diagonal, and that we are saying it's d1. And then for the other diagonal, or the vertical diagonal, I have d2, which is this one. Now when I'm moving on to the kite, it's very similar, although in this case I have the descriptions of a kite. We have two of these that are congruent and then these two sides that are congruent. And so I have this diagonal is D2, and then this diagonal I'm saying is D1. So in order for us to find the area of any of these two rhombuses or kites, we're multiplying the diagonals with each other and then dividing it by 2. And now we are moving on to this first example. So we have find the area of each rhombus or kite. So the very first one, they're telling us that this vertical diagonal is 8 and this horizontal diagonal is 6. And the really cool thing about this formula is it's very easy. We're not doing anything too complicated. We're just multiplying those diagonals and then dividing it by 2. So I'm going to go ahead and do that on this side. So I have 8 times 6 divided by 2. I'm going to go ahead and simplify this. So then 4 times 6 is 24. Okay, and then they didn't give, in the examples on the textbook, if they don't give you any units, then that's all it is. We don't have anything in this case, but if they were to give us units, we'd be making sure that we're matching that. Okay, so then we're moving on to a kite example, and we're doing the same thing. So I have 7 times 10 divided by 2. I'm going to go ahead and just simplify this just to make it easier for me to work with. And then I know that 7 times 5 is 35. So if you notice, whenever you're working with these larger numbers, don't forget to use those algebra skills and just make it easier for you to simplify, and in the end it'll make it easier for you to multiply your problems or your numbers. Okay, so hopefully this one wasn't too bad. I don't think it's too complicated yet. We're going to go ahead and move on to the academic language. Now there are important words that are in this section. So I wanted to go over that part quick before we move on to the next stuff. So for the very first vocabulary term, I have the center of a regular polygon and the radius of a regular polygon are the center and the radius of its circumscribed circle. Okay. Then we move on to the next vocabulary word, which is the apothegm. And the apothegm or apothegm of a regular polygon is the distance from the center to any side of a regular polygon. So I'm going to go ahead and move on to this picture here. From here to here is what we call the apothegm. Okay, so it's not actually the sides of the shape, the triangle here, but it's the distance from the center to, actually no, it could be either one, but normally we say that the apothegm is from here to the actually from the center to the side here. Okay, it's kind of like the height of the shape. So they move on to the central angle of a regular polygon is an angle formed by two radii. This is something that we've already covered. So it is this angle here. And then we move on to the actual formula for finding the area of a regular polygon. So the area of a regular polygon, or n-gon, if we don't know what the sides are, with the side length s, is 1/2 times the product of an apothegm A and the perimeter noted by capital P. So here are two ways to find the area of a regular polygon. So we have, in this case, area equals 1/2 little a, again apothegm, times P for perimeter, or we can find it by saying by using the 1/2 times the apothegm A times the number of sides n with multiplied by s, which in this case s stands for the side length. Okay, so we're going to be using this information to go ahead and do some practice problems in the next video.